Morning class. Another time for this class. Gravitational field. So in the last class, if I can remember, I gave you guys an assignment, a work home assignment that you can do, you can practice. So what we'll do now is before we start the class, I'll just do the correction of that. So if you solved yours, you can just compare the solution that you did with what we have. Okay, so question says two bodies of the same mass, two bodies of the same mass experience a force of attraction 2.82 times 10 raised to the power of minus 7 Newton when placed at a distance of 100 centimeter in a gravitational field. Determine their mass and say take G as 6.67 times 10 raised to the power of minus 7 Newton meters square per kilogram square. Okay, so what I just did here is already brought out my parameters. I don't know the mass of the two bodies, so my M1 and M2, I don't know it. But then it says these two masses, they are the same, which means M1 is equals to M2, right? So I can say M1 is M2 and I can say M2 is M1 because they have the same masses. So now using the formula from Newton's law of universal gravitation, I'll say G M1 M2 over R squared. So here is the gravitational constant and the mass of the two bodies over R squared. So this is it. So what I'm going to do here is I'm simply going to replace my parameters in this equation. What am I going to have? I'm going to have my F. My F is the force of attraction between the two bodies. So I'm just going to write it as 2.82 times 10 raised to the power minus 7 is equal to, what's my G? G is universal constant, that's gravitational universal constant, 6.67 times 10 raised to the power minus 11. Then times, since M1 is equals to M2, I can just say times M times M divided by, now here, this is 100 centimeter, but then the SI unit of distance is meter. So I converted this centimeter to meter. How did I do it? I divided it by 100 because 100 centimeter makes 1 meter. So I divided it by 100 and I got 1 meter. So this is 1 square. So this will give me 1 square is 1, right? So if I cross multiply, I can just say 1 square is 1. So when I cross multiply, I have 2.82 times 10 raised to the power minus 7 times 1. So anything times 1 is still the answer, equals to 6.67 times 10 raised to the power minus 11 m squared. That's 10 times 10. So here what I'm going to do is to get the value of my m, I'm going to divide through by 6.67 times 10 raised to the power minus. So I'll have m squared is equals to 2.82 times 10 raised to the power minus 7 divided by 6.67 times 10 raised to the power minus 11. So here this is going to give me okay, if I divide it, m squared will be equals to 2.82 times 10 raised to the power minus 7 divided by 6.67 times minus 11. Okay, this gives me 4227.88. So now for me to find the value of my m, what I'm going to do is I'm going to find the square root of this. So I'll say m is equal to square root of 4227.88. And this will give me 65.02. So yeah, what I'm simply going to do is I think the question they gave us the answer in the nearest kilogram to the nearest kilogram. So this is 5 here. So I'm going to convert this to the nearest kilogram. So converting this to the nearest kilogram, I can just convert it to the nearest whole number. So I'll say m is equal to 65 to the nearest kilogram. And don't forget, we are working with mass, so my unit is going to be kilogram. So I should have written this here, but I already wrote the nearest kilogram here. So this should be 65 kilograms, which means the mass of the two bodies is 65 kilograms, which is option A. So this is the solution to the question I gave you guys in the last class. So if you got this at 65 kilograms, you are good to go. So now we'll continue from where we stopped last week. Last week we stopped at Newton's law of universal gravitation. So we'll continue, move to gravitational potential. So what's gravitational potential? Gravitational potential is simply the work done at the point of, okay, you can say gravitational potential at the point is the gravitational field, is the work done in bringing a body of unit mass from infinity to that point. So when you have a body or at a point, the gravitational potential of that point is the work done in bringing a body mass from infinity to that point. So now gravitational potential is represented by V, like capital V, and then the unit is joule per kilogram. So the unit is joule per kilogram. Now gravitational potential is represented with a formula. V is equals to G ME over RE over R. So where ME is the mass of the Earth, while R is the distance between the point and then the center of the Earth. From the point, that particular point, the center of the Earth, this is the distance. Why V is your gravitational potential. So G is the, this is universal gravitational constant. Why ME is the mass of the Earth. So now, if you are calculating for mass of an object, when you are calculating the work done to bring a body of mass m from infinity to a point on the surface of the earth, you're now going to use b is equals to gmem over re. Sorry, it should be p equals gmem over re. Why? Because I'm bringing this body of mass m from a point on the surface of the earth to infinity. So which means, and then the distance of any point on the surface of the earth, of a body on the surface of the earth to the center of the earth, is always the radius of the earth, isn't it? So now, like something like you have this is the center of the earth and this is the surface of the earth. So which means the distance from this body to the center of the earth is the radius of the earth, right? So now that means the distance between the body and the center of the earth is the radius of the earth. Why this m is the mass of the earth? Why m is the mass of the body? So now the work done in bringing a body on a point of the earth or on the surface of the earth from infinity to a point is calculated with this formula: V equals to G MEM over RE. So I already explained the meaning of these parameters. ME is the mass of the earth, M is the mass of the body, RE is the radius of the earth, YV is the work done in bringing the body from the center of the earth to infinity. Okay, now, so what we'll be doing is we'll move to escape velocity. Escape velocity. So just clone this. So what is escape velocity? We are talking about escape velocity. What is escape velocity? Escape velocity is the minimum speed needed for an object to break free from the gravitational attraction of a massive body, such as a planet or a solar system. So now the gravitational escape velocity. Now escape velocity is the velocity used like for rockets. Now when they are leaving the Earth's surface or they are leaving the space of the Earth, they are moving to space. Now the velocity, the minimum velocity required for that rocket to break free from this space of the Earth or to break free from the gravitational attraction of the surface of the Earth is what we call escape velocity. So that velocity which is using the minimum speed required for it to break through the attraction of the Earth is what we call escape velocity. Now, escape velocity is this. Now, don't forget, for us to calculate escape velocity, I'm going to show you how it is done. So I'm going to clean this off. All right, so now since we want to calculate velocity, here we are dealing with kinetic energy. Kinetic energy is half mv squared, right? So this is what we use to calculate kinetic energy. Now, if you can calculate very well, this is the kinetic energy of that body, half mv squared. That's 1/2 times the mass of the body times the velocity. So now, which means the work done in moving that body from the earth will be equal to the kinetic energy, which means the work done will be converted to kinetic energy to move the body out of the surface of the earth or out of the attraction, the force of attraction of the earth's surface or from any planet whatsoever. So now I can say work done from moving that body is equals to half mv squared. So now here, if you remember when I was talking about gravitational potential, I said the work done from moving a body from infinity, a body of mass m from infinity to a point on the center of the earth is equal to g MEM over r squared, re squared. Sorry, over re. When I said this re is the body of the is the re is the radius of the earth, m is the mass of the body, me is the mass of the earth. So here we just replace this with work done. G MEM over re is equals to 1/2 mv squared. So now here m is common, right? Which is the mass of the body and the mass of the body. So I can say m can cancel out m. So here I'll just continue and say, here I have, if I cross multiply, I'll say 2g, as this will multiply is 2g me over re equals to v squared. So now I want to find v, which is the minimum velocity. There is escape velocity. I'll just say square root of v. So v is equal to square root of 2g me over re. So now this is the formula for calculating the escape velocity of a body required to escape the velocity of the earth. So g is g is the gravitational potential, universal gravitational constant, sorry. While me is the mass of the body and re is the radius of the earth. So this is the formula for calculating it. Also, if you remember when we're talking about gravitational force, I said gravitational force, that's in the last class. If you missed the last class, you can just go back. I explained all of it in the last class. So you can say G is equals to G ME over RE squared. So I said gravitational force at any point on the earth, which is for gravitational, let's say gravitational force, acceleration due to gravity, which is force of gravity, G, is equals to G ME over RE squared, right? So I explained this in the last class. You can just go back to and you can refer back to it. So now what I want to do here is I want to impute this in this. So if G is equals to ME R square, I can see B is equals to 2GRE, right? How did I get it? If I multiply this by RE, one of these R is going to cancel this RE, and I'll be left with GME over RE, which is this. So I simply saying GME over RE, which is GME over RE, is the same as GRE. Are you guys with me? So now, where my G is GME over R squared. So if I use this R to cancel this R here, I'm still going to have GME over RE. So which means I can say my escape velocity is equal to 2G ME over RE or 2G RE. So now we're going to take an example now. We're going to take an example real fast. Question says, calculate the escape velocity of a satellite launched from the Earth's surface if the radius of the Earth's surface is 6.4 times 10 to the power 6. Okay, I'm going to be working on this side. So I'm going to turn this. All right. I hope you guys are following. All right. So what I'm saying is calculate. Okay, the question is calculate the escape velocity of a satellite launched from the Earth's surface if the radius of the Earth is 6.4 times 10 to the power 6. So radius of the Earth 6.4 times 10 to the power 6 meters. Don't forget the formula is 2G RE, right? So now, don't forget this acceleration due to gravity is always 10. So I can take acceleration due to gravity as 10, right? So my G is equals to 10. So I'm just going to use this formula for my escape velocity of CV is equals to square root of 2 times 10 times 6.4 times 10 to the power of 6, right? 2 times G times my G is acceleration due to gravity, which is 10. So what I'm going to do here is I'm going to do 2 times 10 times this. So this is going to give me, if I say 10 times 6.4, it give me 64, then times 2, 1.8. So this will be 1.28 times 10 raised to the power of 8. So what I'm going to do here is I'm going to find the square root of, so this will be G is equals to 1.12 times 10 raised to the power of 4. So what I did here is I just simply evaluated what is here. So evaluating what is here, I said 2 times 10 times 6.4 times 10 to the power of 6 was what gave me 1.2 times 1.28 times 10 to the power of 8. So after doing this, I multiply. I found the what am I saying? I found the square root of this, and I got meter per second. So now here in the question is giving me my answer in not in meter per second, but then in kilometer per hour, which means I'm going to convert this to kilometer per hour. So converting this to kilometer per hour, I can say this is equal to 1.12000. That's 1, 2, 3, 4. Just 1, 2. Okay, so this is it. So converting this to kilometer per hour, I'm going to simply divide it by 1,000. So dividing this by 1,000, this will become 11.2 kilometer per second. So my answer here is option D, which is 11.3, probably approximation stuff when we are approximating. So my answer will be 11.3 kilometer per second, which is option D. I hope you guys got how I did it. I replaced all of this into my parameters. I replaced all the parameters into the equation, that's into the formula. This is G, which is 10, 2 times 10 times 6.4 times 10 to the power of 6. I got this and I found the square root. The square root gave me this. So what I simply did is I converted this from meter per second to kilometer per second. Also, I can do it in another way by converting this first to kilometer per second and to kilometer, this radius to kilometer, instead of leaving it like this in meter. So if I'm converting it to kilometer, I'm going to use this place. So I'll say RE is equals to 6.4 times 10 to the power of 6 meter. If I'm converting it to kilometer, it becomes 6.4 times 10 to the power of 3 kilometers. So I'm going to do this. E equals to 2 times 10 times 6.4 times 10 to the power of 3, right? So how did I got this? I divide this by 1,000. So if I divide this by 1,000, I'm going to add this as I converted this meter to kilometer. So here I'm going to say this. This is going to give me 1.28 times 10 to the power of 5. All right, so this now become V equals to 1.12 times. Okay, let me do it. Coming. All right. So this will give me, let me just do it directly. 1.13. 1.13. All right, so the square root of this is going to give me 1.11.3. But something is, I think something is wrong here. Coming 10 times 2 times 6.4. So the square root of this would be, sorry, I think that was my calculator's error. So this is 113.13 kilometer per second. I think the answer is not even there, or maybe probably it was issue from me or something. Let's check again. I said 2 times 10 times. Okay, all right. I think the issue was coming from here. I think I made a mistake here. So when I find the square root of this is supposed to give me what this. It should give me 1.7. So what I'm going to do is I'm going to convert this to kilometers. So converting this to kilometers, I'm going to divide this by 1,000. So this will be, if I'm dividing this by 1,000, that's divided by 1,000. I'll have one. Let me divide it here. So I'll have 11.3 kilometer per second. So here is the answer. I think this was where the mistake was coming from. So this should be 113.7. So I can just leave it as 11313. So when I divide it by 1,000, that's converting it to kilometer per second. I'll have this 11.3 kilometer per second. So here is the answer here. So now that's option D. Okay. So moving to the next topic. So moving ahead, we'll move to the next topic, simple machines. All right. So simple machines, that will be the next topic. So you can just get your first question, and then all these questions are there, you can practice them. And then just do well to practice them. Okay, what is a machine? A machine is a device which enables mechanical work to be performed in a more effective, convenient, and efficient way. That's a machine, a device which enables mechanical work to be performed in a more effective, convenient, and efficient way. So examples of simple machines includes lever, the pulley system, the wheel and axle, the inclined plane, and the screw. So those are examples of simple machines. So we take them one after the other. So we'll start from lever. A lever is a simple machine, consists of a rigid bar or rod pivoted at a fixed point. So here is an example of the lever. The example of lever is your scissors, your shear, wheelbarrow, they're all levers. The crowbar, they're all levers. So let me say something like this. Here is fulcrum, and then here can be load. Just giving an example. So here is fulcrum. Call this fulcrum, you call this effort, and this is load. So now you are applying effort on this to make this for this example of lever. Lever which contains a simple machine consisting of a rigid bar pivoted as a fixed point. That fixed point is called the fulcrum. And then okay, called the fulcrum. So for the lever, so we'll be moving forward. For a lever, the mechanical advantage is given as so in a lever like this, for this example, this is just a representation of a lever. So now for a lever this way, say the mechanical advantage. The mechanical advantage is given as load over effort. First of all, what's mechanical advantage? Mechanical advantage is simply the measure of how much a machine multiplies force or distance. The measure of how much a machine multiplies force or distance. So now the mechanical advantage of a lever is given by load over effort, right? And my load is W, while my effort is F. So mechanical advantage is equal to W over F. Your W is your load, while your F is your effort. So now my velocity ratio of a lever is calculated as the distance moved by load over distance moved by effort. Now this is it. So the distance moved by load, I can call it X. While the distance moved by effort, I can call it Y. So the distance moved by load is my X. The distance moved by effort is Y. Or you can say D distance moved by effort over distance moved by load. So this is velocity ratio. The velocity ratio calculating velocity ratio of a lever is distance moved by effort over distance moved by load. Now moving forward, you can say efficiency. What's the efficiency of a machine? The efficiency of a machine is simply the work done on load divided by the work done by effort times 100 over 1. So efficiency is work done on load over work done by effort times 100 over 1. So now what's work done? Work done is simply force times distance. So now what's the force of the load? Force of the load is W times distance moved by load, GL, over work done by effort, F times DE. Isn't it? So here is this. So I can simplify this. Don't forget times 100 over 1. So this will become E is equals to this DL. I can say W times DL, which is this, divided by F in DE as this. All right. So since I have this, I can simply say, since my mechanical advantage is this, I will just say this is equals to WF over DE times DL. So here I can now say E is equals to mechanical advantage. Since my WF is mechanical advantage over GE over DL is my velocity ratio. So over velocity ratio times 100 over 1. I guess we are cleared. So now what I just simply did here is breaking this down. Breaking this work done by effort over work done by load. I'm breaking it down times 100 over 1. I'm breaking it to become mechanical advantage over velocity ratio. So your efficiency, the efficiency of the machine is mechanical advantage over velocity ratio. Why the mechanical advantage is load over effort. The velocity ratio is distance moved by effort over distance moved by load. Why your efficiency is mechanical advantage over 100 or work done on load divided by work done by effort times 100 over 1. I guess we are clear here. Okay, now, so what we are going to do is, okay, we'll take an example. Example 1. What effort will a machine of efficiency 90% apply to a load of 180 Newton if its effort arm is twice as long as its load arm? All right. The question says, what effort will a machine of efficiency 90%? So the efficiency of the machine is 90%. Apply to a load of, my load is 180 Newton. So we are asked to look for effort. I don't know my effort. If the effort arm is twice as long as the load arm, so effort arm is simply the distance moved by effort. So my distance moved by effort, DE, is twice as long as the distance moved by load. isn't it? It's twice as long as the distance moved by load. So which means my distance moved by effort is 2 times distance moved by load. And don't forget, my velocity ratio is equals to distance moved by effort over distance moved by load. So here I can say D distance moved by effort, which is DE, equals to 2dl. So instead of writing 2dl, I can just instead of writing this DE, I can replace this DE with 2dl. So I can say my velocity ratio is equals to 2dl over dl. And here dl can cancel out dl. And then my velocity ratio is 2. So moving forward, I said efficiency is equals to mechanical advantage over velocity ratio times 100 over 1. So here my mechanical advantage, I don't know it. So here is my efficiency is 90%. 90 is equals to mechanical advantage over 2 times 100. So when I cross multiply, I have 180 is equals to 100 times ME. Sorry, ME. So dividing through by 100, I have my mechanical advantage to be equals to 1.8. So now, since my mechanical advantage is equals to 1.8, and we are not asked to find mechanical advantage, don't forget, I'm asked to find the effort. And then mechanical advantage, don't forget, is equals to load over effort. Load over effort. So what is my load? My load is 180 Newton. And my effort is what I don't know. That's what I'm looking for. The mechanical advantage, I just calculated it as 1.8. So if I cross multiply, I'll have 1.8 F is equals to 180. And here I'm going to divide through by 1.8, right? So I'll have F is equal to 180 divided by 1.8. So if I do this, and I divide 180 by 1.8, I'm going to get 100. So my F is equal to 100 Newton, which means the effort taken to move a machine, taken to move a load of 180 Newton by a machine of 190% efficiency is 100 Newton. So my effort is going to be 100 Newton, which is option A. Okay, I think you guys are following me. Okay, so I'll move to example 2. A machine whose efficiency is 75% is used to lift a load of 1000 Newton. All right. It says a machine whose efficiency is 75% is used to lift a load of 1000 Newton. Calculate the effort put into the machine if its velocity ratio is 4. So now it says the velocity ratio is 4, right? The velocity ratio is 4. Why the machine, the efficiency of the machine is 75%. Efficiency of the machine is 75%. Why the load, which is W, is 1000 Newton. Now the question says calculate the effort put into the machine. So what I'm going to do is efficiency is equal to mechanical advantage over velocity ratio and 100/1. Very similar to what we did. So this one is 75, which is my efficiency. Mechanical advantage, I don't know it yet. My velocity ratio is 4 times 100/1. If I cross multiply, I'll have 4 times 75, isn't it? It will give me 300 is equal to 100 MP. And then here I'll divide you by 100 to get my MA, which is mechanical advantage, and I see my mechanical advantage is equal to 3. Now, for me to get my load, sorry, the effort, what I'm going to say is mechanical advantage is equal to load over effort, right? So yeah, my mechanical advantage is equal to load over effort. And what is my load? My load is 3, which I just calculated here. So I say 3 equals to 1000 over x. So if I cross multiply, I'll have 3x equal to 1000. And here I can divide through by 3 to get the value of my x, which is my effort. Don't forget, effort is what I'm looking for. So if I divide through by 3, I'll have 1000 divided by 3, which is going to give me 333.3333. The unit is Newton because we're calculating force. Effort is Newton. So I think my option there should be okay, 0.33, 2 decimal place. So my answer there is the effort put into the machine is 333.33, which is option C. That's it. We have option C. And then so that will be the examples we'll be using. So we'll be moving to the next one, pulley system. All right, pulley system. When we are talking about pulley system, what's a pulley system? A pulley system is simply a mechanism consisting of one or more pulleys and ropes or belts used to transmit motion or lift loads. A pulley system is a mechanism consisting of one or more pulleys and ropes or belts to transmit motion or lift loads. So it's a type of a machine. So the velocity of a pulley system is simply calculated by the number of pulleys in the system. Okay, which means I'm going to count. Okay, let me say, for example, I have something like this. I have a pulley like this. Whatever my drawing is bad. Okay, I have something like this. Okay, let me say I have something like this. This is a pulley, right? So if this is a pulley and I want to calculate the velocity ratio of this my pulley, so what I'm going to do here is for me to know the velocity ratio of this pulley, I'm going to count one, two, three, four. The number of pulleys in the pulley system is what I'm going to count. Sometimes pulley system is called block and tackle. So I'm going to count the number of pulleys in the pulley system, one, two, three, four. So my velocity ratio will be 4. If there are 5 pulleys in the pulley system, my velocity ratio will be 5. If there are 7 pulleys, my velocity ratio will be 7. I think we are cleared. So now we'll move on. So let's take an example. Let's take an example. Diagram shown represent a block and tackle pulley system on which an effort of W Newton supports a load of 120 Newton. If the efficiency of the machine is 40%, then what is the value of W? Now, don't forget, efficiency is equal to mechanical advantage over velocity ratio times 100 over 1. So now, the velocity ratio of this pulley here, if you look at this pulley here very well, on the diagram on your screen, you can just look at the number of pulleys in that pulley system. You're going to count it very well. You find out that you have 6 pulleys in that pulley system. So here, if you count the number of pulleys in the diagram there, you find out that it is velocity ratio will be equal to 6. Question also says my efficiency is 40%. And it says I have a load, which is my load is 120 Newton. Now says find the value of W, which is my effort. So that's what I'm looking for. So what am I going to do here? What I'm going to do here is I'm simply going to say efficiency is equal to mechanical advantage over velocity times 100. So here if I cross multiply, I'll have 6 times 40, which should be 240, equals to 100 MA, which is my mechanical advantage. So what I'm going to do here is I'm going to divide through by 100 to get the value of my mechanical advantage. So I'll say mechanical advantage is equal to load over effort. And don't forget the value of my load is the value of the load in the question is 120. Why the effort is what we are asked to look for. So I will just continue this from here. Mechanical advantage. Here, what I'm going to replace is I just calculated mechanical advantage as 2.4. So I'll say 2.4 is equals to 120 over. So now cross multiplying, I'll have 2.4 plus 120. So to get the value of my effort, I'm going to divide through by 2.4. So dividing through by 2.4, I'll divide 120 by 2.4. If I divide 120 by 2.4, all right, yeah, my answer is 50. So when I divide 120 by 2.4, I get 50. So the value of my effort is 50 Newton. This is option D. So what you just do is you impute your parameters in the equations, and that's what I did here. I calculated my mechanical advantage first, and I got 2.4 as my mechanical advantage. Don't forget, mechanical advantage and velocity ratio, they don't have units. But then effort and load, the unit of your effort and load is Newton. Why unit of your efficiency is percentage? That's why you can see my efficiency is percentage. My velocity ratio here doesn't have a unit. Why my load is in Newton? So the effort I just calculated right now is going to be 50 Newton. So moving to the next question, it says a pulley system, that's the next example. A pulley system has 3 blocks in the fixed block has three pulleys in the fixed block and two in the movable block. If the pulley has an efficiency of 72%, the mechanical advantage of the system is okay. So the question says the pulley system has three pulleys in the fixed block and two in the movable block. So if the efficiency of the pulley system is 72%, find the mechanical advantage. Question says that find the mechanical advantage. Don't forget it says three pulleys in the fixed block and two pulleys in the movable block, which means 3 plus 2. My velocity ratio will be 3 plus 2, which is equal to 5. That's total of 5 pulleys in the system. So now efficiency is equal to mechanical advantage over velocity ratio times 100 over 1. So here I'll say my efficiency, which is 72%, is equal to my mechanical advantage over my velocity ratio is 5 times 100 over 1, right? So if I cross multiply 72 times 5, I'm going to get 360 is equal to 100 ME. So I'm going to divide through by 100 to get the value of my mechanical advantage. So my mechanical advantage will become 3.6, right? The question says I should find mechanical advantage. So 3.6 is my answer, option D. So that's option D. So we are going to move to wheel and axle just 2 minutes and then few minutes and then we'll end the class there. So wheel and axle is simply a simple machine consisting of a wheel attached to a smaller axle where the wheel rotates around the axle. So the work done by effort, right? The work done by effort by simply distance movement. Effort itself. Distance moved by effort itself. Why the work done on load is 2 by R W. So now this R here is simply the radius of the wheel, while this small r is the radius of the axle. So now the distance moved by effort is simply, oh sorry, the work done by effort is 2 pi rf, while the work done on load is 2 pi rw. That's this r on the load is small letter. So which means the efficiency of a wheel and axle system is going to be by effort. So this will be W, efficiency is E, is going to 2 pi r f over 2 pi r w times 100 over 1. So here is the efficiency of this system. So I can say efficiency of a wheel and axle system is equal to 2 pi r f over 2 pi r w times 100 over 1. Why the velocity ratio of a wheel and axle system is the radius of the wheel divided by the radius of the axle. So here is where we are going to end this class. So you can do well to take your practice questions and then I'll see you in the next class. Goodbye.